Whatever water's here now is tiny compared to what once was. There's a growing body of evidence that early in its history, Mars was on track to become positively Earth-like. But something went horribly wrong. Not long after its birth, the planet's molten interior welled up to spawn volcanoes and hot springs, spewing gas that formed an early atmosphere. As the atmosphere thickened, carbon dioxide began to trap heat from sunlight. In other words, the classic greenhouse effect. Temperatures rose high enough to allow liquid water to flow on the surface. What then caused these waterways to evaporate, and the planet to grow cold and dry? In search of the answer, the Mars Global Surveyor spacecraft was brought down to a low altitude, and it made an intriguing detection. MGS documented the presence of a small magnetic field emanating from the planet. It's incredibly weak compared to that of Earth. Our magnetic field is generated by molten rock deep in Earth's core that rises and falls into a huge region below the outer crust called the mantle. That has turned our planet into an electric dynamo. The rising and sinking motion within, combined with the spinning motion of the planet, generates a strong magnetic field. This field is strong enough and extends far enough into space to deflect the wind of high-energy solar particles, protecting Earth and its atmosphere. In its early years, Mars too appears to have had a robust magnetic field. Rocks in some of the older craters bear a strong imprint of this field, while newer ones indicate a much weaker field. So what caused Mars' magnetic field to drain away, exposing the planet to solar winds? The answer lies in its violent past, a past that today is still written on the landscape. This is high elevations of the South. Mars is a lopsided planet. And here's why. Early on, when the solar system was young, Mars was apparently hit by at least 15 large asteroids. One of them was large enough to turn most of Mars' northern hemisphere into one huge impact feature. Earth too was walloped by objects this big, but because Mars is small, only about half the diameter of Earth, and has only about a third of Earth's surface area, the effect would have been much more profound and long-lasting. The thinking is that these impacts heated the outer subsurface layer of the planet, the mantle. That prevented molten rock in its core from rising up, and switched off Mars' magnetic field, probably forever. Without its electromagnetic deflector shield, solar radiation began to lash the planet, gradually stripping it of its atmosphere, and thus its blanket of warm air. What water Mars had would have vaporized into space, or frozen underground.